It all has to do with that formula there. You wrote it on Friday. So the exponential graph. So we practice plugging in and using a calculator into the fourth
Okay.
Actually, this is what we did in class.
Oh,
You can
video.
keep it if you want. We did 139.
Okay.
So if you watch the video, those are the problems that it shows.
Okay.
Who else was absent yesterday?
How do you turn this on?
How'd you know I was absent? Because the class was quiet. Yeah, right. You guys didn't know if I was here or not. Because I was an angel. What? I don't have one of those.
What band is this?
So which one was the most confusing out of 1 through 8?
Two. I got stuck on two. I don't
So
know.
you look at these answers. So you guys need me to write out the formula for number 2?
I got that one. I don't know. I was doing something wrong. I mean, look at my thought process. I crossed it out. I ended up getting like a big decimal. I'll smell it.
So it says quarterly in number 2. And that was no, we didn't get to quarterly until we did number 9 yesterday in
Yeah,
our
I
word
got
column
three
handout. So here's the formula you're supposed to do. If it says quarterly, you gotta divide your interest rate by 4 and multiply your years by 4.
Two?
Semi-annually is twice a year. Obviously, you have to have a calculator. Calculator check in 2 ways. These word columns are meant to be used with a tool. Because of the word semi-annual. Semi-annual means they're giving you the answers twice a year.
I was off. About $310. I got a horrible number. Nowhere near that.
As long as you write the formula down in that calculator, you have my permission to do it all in one operation. Put it all there together. Gave you fixing the ones you didn't do correctly?
Yeah. Okay, yeah, I got that.
Huh? I think so.
I don't know. I just pressed the button. You can even put it in your calculator. Oh, I found it. It's right here. Damn. Oh, I got the calculator. Did he please start?
Don't think it's Libby distracting you. She's oh, always. She always is something. It's always Keyshawn.
Oh. She did it.
Her buddy. Don't mean it.
That's crazy.
Oh, I got it. Oh, come on. You can get the better air out.
I know.
Oh, found it. Seven. OP not defined. Look at that.
Like Libby today. He's gonna break that.
Not defined. That's what is wrong with it.
To me, yeah.
I said it. Let me fix that.
That's not really what it's all about. It don't help.
I'm gonna Spider-Man Far From Home. And
You want actually like all of it? Cut 2 inches off.
nah, this is brutal.
2 inches is a lot.
Go straight to the point. Go straight to the point. I was gonna say forever to do that. I literally spent an hour downloading this shit so much.
Three's too many.
Yeah, that's not usually.
Did you guys
It
just
starts
figure
off
out the subject after?
Wow. Did it happen like 2 days ago? No. I found it just like yesterday.
Oh my
Do you know why? Oh, shucks. What?
Did you actually get
I need to shave. I need to shave these sideburns, bro. Jeez.
Okay, I think I've checked everybody, right? Okay, I'm gonna do number 8, I think.
Oh, okay.
Do number 8. Does anybody have a different request? If you have a question about your calculator, I really want to show, this is our chance to really show you how to use that tool well. So I will take the time to look at your calculator and work it out with you. Let me know. Okay. So what's so cool about number 8 is that it's giving us the end population. This is the only problem so far where we've been given the end population instead of the starting population. It says the population was 11 million in 2000, not in 1995. But did any of you catch that? That it was the end population at the beginning? So I'm actually going to put 11 million here. Oh, wait. It's asking you about 2050? Oh, sorry, no. Erase everything in this too. No, this is the same as we've been doing. I apologize. So it's 1 minus, this is 0.0005. This is why we had well work yesterday. This is a percentage, so you have to continue 2 decimals to the left. So we gotta put a 50 in here. Yeah, that's the answer. Sorry, but on my previous words, that's just like what we have to do. Anybody have a question? What about any of the other problems? Should I do any of the other ones? Fine. Fine. Don't ask any more questions. Fine. Let's just move on to graphing then. You guys just must write and keep. You can write on this and keep it. I want you guys, when you get this, to try to fold it. Remind me of the summer sky.
Which side or
Try to fold your hand out on the line. It's a hot dog fold. Try to fold it. This left side of, you're quiet. I'm starting. So if you fold this way, the left side is graphing a linear function. See, there's two different headings. The left says linear function and the right says exponential function. You already, okay. Besides the words, what's the difference in the equations when you compare the linear function to the exponential function? What's different in the equation?
One squared.
wait, are we folding it like outward or this? Not perfect.
Libby, what's the difference in the equations on the left and the right? Why won't it work? What's the difference in the equations on the left and the right? That's it, guys. One has an exponent and one doesn't. So if the x is down regular, it's called linear. If the x is up high, it's called exponential. All right, you guys already know how to do the linear. So complete the table. You're plugging in for x. You're completing a table. Read the questions, try to answer it, try to graph it. The left side of this is old news. You already know how to do it. But you have to be able to compare the left side to the right side. That's the standard. So go ahead, work on the left side of the paper. You can talk about it in your groups. Complete the table. Complete the table.
Would it just be 2, 4, 6, 8, 10? Huh?
I kind of went above and beyond here. Just check your numbers. I'm looking at your tables and I'm seeing your numbers right. And you didn't really have to show a lot of work, and I'm fine with that. So get your ordered pairs and go ahead and plot that on the graph there at the bottom. Make your linear graph, something you already know how to do.
It's this one, right? And open it. No, the stuff that we're doing right now is in this one.
There's no what?
Jake.
There is no person that has established which way is right.
Jake.
Look at the astronomical.
Hey, Jake. 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 Let him be the way he wants to be, alright? Yes. No. Exactly. Jake, how about you're wrong, Jake?
Why are you butting in our conversation?
Guys,
Put your hood down.
Sometimes you need a third party. Speak the truth.
it's cold, Jake.
You always need a third party.
He's the remediator. Did you guys have that in elementary school or middle school? You had like a remediation peer?
I know what a mediator is.
No, that's what I meant, mediator. Okay. Alright. How are the Y values changing? Was anybody able to answer number 2?
Why values changing?
How are the Y values changing? Yes, Kalia. These are going up 2 every time.
Increases by equal to?
I don't know what I meant to put there. Increasing. I'm going to actually say by adding to really put a lot of description here. Those are called equal differences. The difference between each one is 2. Alright, so, oh yes, this is a linear pattern. That's why it's called linear. We're going up 2 every time. You're adding 2. They have equal differences. We know what a linear equation looks like. This particular linear equation has a special name. Does anybody know? If it goes through 0, 0 and has a constant slope. The initials are dv. Yeah. This is a direct variation, but that's only because it goes through 0, 0. Direct variation. Boom. So hopefully you're graphing this and you're thinking, oh yes, I see this has a rise over run. Up 2 over 1, up 2 over 1. Hope y'all are on the right side. These are on the left side. Okay.
Would you rather 1, 2, 3, 4, and 5 be on the inside or the outside?
You're behind. Okay? Your joke is old now. You're behind. Look, I'm already on number 4. Was everybody able to get a line that starts at 0, 0 and has a slope of up 2 over 1? Up 2 over 1. Those constant first differences are actually a rate of change of slope. Everybody really getting flashbacks to last semester. Let me know, like, 4, you're just flipping to the right side, you're like, whatever, boss, I'm ready for exponential. Okay. No, it's cool. I'm inspired. Okay, describe the line. Okay, so once again, this line is linear. This y-intercept is 0. This x-intercept is 0. Oh, I guess I should have put the word. It has one name, linear. Of course it's linear if the name is linear. The end behavior. Okay. goes down on the left, goes up on the right. I don't think you guys have ever talked about end behavior before. We talk about the ends of functions a lot as functions get more interesting. And we talk about what their arrows do on the ends. This one goes down on the left and up on the right. But some functions go up on both sides, the parabolas, the U shape. Some functions go down on both sides. Okay, are we ready for the right side of the hot dog? Okay.
I'm tired.
All right, if you think you can, go ahead and try to get your table right on number 5. So flip to the right side. That left side was old news. The right side is what's new to you.
Wait, it's the same thing for the table.
But I applaud your effort. Yeah, we're on number 5 now. The whole point of 1 through 4 is to make sure you can clearly see the difference between what you used to know and what you're about to do.
There's an exponent.
It's floating on the inside, is it not? No, it's holding outward. It's holding outward, right?
Look, Jake.
Yeah,
you're wrong.
What did I say?
I tried not to tell you, but over it now.
So who's wrong, Jake? Jake, who's wrong?
Oh my
You.
god.
You're wrong.
Okay.
Like always. You.
I don't care that you hurt your knee.
Wow. Wow. You know what I don't care about? How you broke your arm. And out for the rest of the football season.
I don't even know why we're talking about this. Stop. You guys, honestly. Can anybody figure out what 2 to the negative 2 is? I'm pretty sure everybody has it wrong. Ada Marie's going to figure it out. It's not 4. Logan? Yeah, 1 of them. Okay. I want the fraction form, but I applaud your right answer. So this is so we're plugging in for exponents on this side. So 2 to the negative 2. You have to remember that negative exponents make fractions. So this is actually 1 over 2 squared, right? Negative exponents go under 1 and become positive. So this is 1/4. Okay, so our first point in this function will be negative 2, comma 0.25. I want your fraction answer, but I want you to put it in a decimal if that's going to help you graph it correctly. Okay, then what do we think 2 to the negative 1 is? 1/2. 1/2. That's 1 over 2. So our next ordered pair is negative 1, 0.5. Okay, I can't wait to hear everybody get this right. 2 to the 0 power is 1, not 0. It's going to really mess your graph up if you don't know your power of 0.
It's going to be 1, isn't it?
Okay. Now these next two are like old news, 2 squared, 4, nothing interesting about that. It's always been 4. Oh, I messed it up. That looks funny. I hope so. 2 to the first is 2. So our next ordered pair is 1, 2. And 2 squared is 4. So now we're at 2, 4. I guess we should finish the table like we did on the left side. And do 3 and 4. 2 to the third power, that's 2 times 2 times 2. What is that? 8. So we have an ordered pair at 3, 8. And 2 to the fourth power, 16. So now we have a number way up at 4, 16.
I don't like these exponents. So confusing.
Well, it's really interesting because even though we have negative x values, we don't have negative y values because negative exponents don't make negative numbers. They just make fractions. You behind? I'm moving on. Moving on. All right. How are the y values changing? So it's hard when you look at the decimal. Does it make sense? Aiden, you got it? You got the pattern? How does this go to this? How does 1 become 2, 2 become 4, 4 become 8, and 8 becomes 16? Multiplying by 2 times 2 times 2 times 2 times 2. Oh, this type of pattern is called geometric. And this is increasing by equal factors. Or we could say multiples. So seeing these side by side is really important. Some people can learn the linear and then they learn the exponential and their brains never connect or compare the two. Can you compare the difference between adding 2 every time versus multiplying by 2 every time? That's linear versus exponential. All right, let's take a look at the graph. Does anybody need me to wait before I scroll? Okay, so how do we graph? It's -2, 0.25 is right there. Okay, it's in the middle zone. You know, not on the line. It's supposed to look not halfway. Mine kind of looks halfway, but it's a little bit of an estimate. You're just 1/4 of the way up. And then -1 is 1/2, so that you just try to make it look like it's just a bit higher, you know? It is weird. 0, 1. What was 1? 1 was 2. 2 is 4. 3 is 8. And 4 is, boom, 16.
Okay, buddy. You always have to comment.
So watch when I connect this is actually really important. The thing is that negative exponents will never make this a negative equation. This particular function will never be negative. So the line gets like really, really close to the x-axis, but it doesn't cross it. And it curves up, and then it goes up forever, really high. But over here, it flattens out. It never crosses negative. So the reason it never crosses negative is you could put some crazy negative number up in the exponent, and it's only going to make a negative decimal. Like, let's try 2 to the -10. We better not go that high. In your calculator, what's 2 to the -5? You got it, Gabe?
1/32.
Shoot. Can you make your decimal for me? It is 1/32. Can anybody do 1 divided by 32 and get a decimal? Is it scientific notation? Stop. Yeah, okay. 0, 3, 1, 2, 5. So even here, if I wanted to put a point in here at -5, it's just really close to 0. It will never perfectly equal 0, and it'll never cross down there. Actually, I want you guys to draw a dashed line here. This is a line that this function will never go below. Over here, it gets closer and closer to the line, but it never perfectly touches it. This dashed line has a really funny name. That dashed line is called an asymptote. An asymptote is an invisible line that a graph gets closer and closer to. It's like a magnet. The end of the graph is like drawn to this dashed line like a magnet. Because our function, the more negative x gets, the closer it gets to 0, but it never perfectly equals 0 or crosses 0. Asymptote. Okay, so what we can say about the line, again, this is what a picture of an exponential function looks like. The y-intercept is 1. The x-intercept does not exist. The line will never cross through x. It's just impossible. Like, you could try numbers all day long in this equation. You could try numbers all day long in for x, and you'll never get a 0 out. So if y will never be 0, then it's never going to have an x-intercept. Because, if I put a 0 in here, I get a 1 out. And if I put a negative number in here, I get a decimal out. It's impossible to create 0. So it's impossible for this line to go through the x-axis because the line will never perfectly equal 0. So the x-intercept does not exist. This is a nonlinear line. Thank goodness you guys are bored of graphing those straight lines. And the end behavior. On the left, the graph flattens out. On the right, the line goes up forever. How do you guys feel about this symbol? You know it? The sideways 8. Infinity. All right, we use the infinity symbol when we talk about the ends of graphs because, on the right side of this graph, the arrow goes up, the line's going up to infinity. So I'm going to say on the right side, the line increases to infinity. And beyond. What's beyond infinity? Yeah, infinity double.
Are you dumb?
Tony, now you just crossed the line because I said we're not going to. It's not professional.
Sorry. Are you absolutely dreaded me?
Okay.
You ruined it.
So tomorrow we are going to continue the back of this. Wait. Let's skip down here to 8, 9 because I gave you 4 of these. I give you a graph to try. I hope that you try to make a table and graph it. I might. If you're, as long as your effort give you credit for it, it should be a little bit challenging. But I want you to do all 4 of the ones that look like this. It says determine whether the data shown below displays exponential behavior. Write yes or no, explain why not. What should we do to decide if it's exponential? What should we look at? How we're changing every time, right? So what's happening here? Wow, this looks familiar.
That one is not exponential. It's 9. 9 is exponential.
Okay, so this is not exponential because it's what?
Adding by 2.
This one is linear because it adds 2. However, this one, what's the pattern in the second one?
Times 4. Like
It's timesing 4, so yes, this one is exponential. It's going up by multiples.
Now, do you agree with that answer? Or it's not at 40.
Alright, y'all. So